this example, we are going to approximate the area, the case key term that approximate the area of the region bounded by the graph f of x equals e to the power 2x and the x-axis. So the function is non-negative because the exponential is increasing graph, okay, on the interval 1 to 4 with the n equals 6 subintervals. If we suggest the graph, I put in the bigger area here. For x0, the function is 1. So the graph is some like this. Okay, this is the y and this is the x. And we're going to start at x equals 1 to x equals 4. 1, 2, 3, 4. Okay. And then we're going to make it into 6 subintervals. The steps of the Riemann sum, you're going to make into n equal subintervals with the total length, like from 1 to 4. The total length can be 4 minus 1. That means that the width or the delta x is from the formula like b minus a, which is the total length, divided by n, or the number of the subintervals. So b is 4, a is 1, divided by 6. Then the width is going to be 1/2. Okay, it's 1/2. Then 1/2, what does it mean? We're going to break it into 6 equal subinterval with the width of the 1/2. So that means we make the partition 1, 2, 3, 4, 5, 6, 6 of them. So the next one is 1.5, and then 2, 2.5, 3, 3.5. Okay, and 6 equal subintervals, and then part A and B, we are going to use part A use the left endpoint and part B use the right endpoint. From our case here, I'm gonna draw another real number line to represent all the points that we're gonna use, starting from the A, which is 1. So the next gonna be 1.5, and then 2, 2.5, 3, 3.5, and the last one is 4. So total we have 7 points for 6 subintervals. Okay. For the left end point, for the first interval, the left end gonna be 1, and the next left end, we use all the 6 left end points except the last one. Okay, the last one is considered the right endpoint of the last interval. So for the point that we're gonna use for the left endpoint, gonna be x equals 1, 1.5, 2, 2.5, 3, 3.5. These are the left endpoints. And to approximate the area using the left endpoint, so I'm gonna use the notation. I'm gonna use the A subscript L from the left approximation. Okay, the Riemann sum is the sum of the function values of all left endpoint multiplied by the width, which is the delta x. Okay, I'm gonna write it as the sum of the function at the first left end, the second left end, and so forth. And then multiply by the width, which is delta x. Now, the function is provided as e to the power 2x. So then the function at 1 gonna be e to the power 2 times 1, or power e to the power second. Plus, I'm gonna rewrite 1.5 as 3 over 2, just for our convenience. Because we have 2 multiplied by x, we don't have to deal with the decimal. So this is 7 over 2. So the second one, the function value gonna be e to the power 2 times 3 over 2. Right? So 3 times 2 times 3 over 2. And the next e to the power 2 times 2, e to the power 2 times 5 over 2, e to the power 2 times 3, and the last is e to the power 2 times 7 over 2, and all multiplied by the delta x, which is 1 over 2. And what we have to do, put in the calculator. If you simplify a little bit, going to be e to the second plus e to the third plus e to the fourth plus e to the fifth plus e to the sixth. Um, oops, plus e to the 6 plus e to the 7 and multiply by 1 over 2, and the number in the calculator. If you could help me check, and my calculator tells me that the number come out to be 865.275. So let me, um, from the graph, as you see, we use the left end. So the left end is the height of the bar. It looks like we are losing like the area for every single bar. Okay. So this case, so the note here, the f of x, which is e to the 2x, is increasing function. Okay, increasing function. And then note this, that means if we use the left endpoint or the left approximation is under approximate or underestimate, because you are losing all the time. So this approximation is technically much lower than the exact value. So that's the note or the observation. And I hope you can see clearly when we get to the second part, which is when we have to use the right endpoints to calculate it. Okay. So question on part A. Nope. All right. So the second part, we use the right end with the same function, the same way to make it into 6 subintervals. So for the right endpoint, from the real number line here, the first subinterval, the right end is 1.5, the next right end is 2, next right end 2.5, 3, 3.5, and 4. So we omit the very first one, which is the left endpoint of the first interval. Then we make a list, the point of calculation. We're going to use the point 1.5, 2, 2.5, 3, 3.5, and 4. So 1, 2, 3, 4, 5, 6, 6 of them. Make sure when you have 6 subinterval, you have 6 points of calculation. Then now the area using the right endpoint is from using the function value. Again, 1.5 is 3 over 2. 2.5 is 5 over 2. 3.5 is 7 over 2. So the function at 3 over 2 plus the function at 2 plus the function at 5 over 2 plus the function at 3 plus the function at 3.5, which is 7 over 2, plus the function at 4, and then multiply by the delta x, which is the width. So the height times the width. And the function, again, use e to the power 2x. So e to the power 2 times 3 over 2, e to the power 2 times 2, e to the power 2 times 5 over 2, e to the power 2 times 3, e to the power 2 times 7 over 2, and e to the power 2 times 4, multiplied by 1 over 2. Or compute the sum of e to the third plus e to the fourth plus e to the fifth plus e to the sixth plus e to the seventh plus e to the eighth, and multiply by 1/2. And my calculation comes out to be, let me see, e to the 1, 2, 3, 4, 5, 6. I get 2 35, 2.06, 1.522. Yep. hmm So it's much more than the first approximation. And from the graphical way, as we use the right endpoint, looks like we gain extra area for every single calculation. To gain. That's why it's it's greater than the approximation using the right endpoint. And another note, which is similar to what we put on as an observation of the first part, the function e to the 2x, yes, it is increasing. So then the right endpoint, the right end approximation is overestimated. Okay, it's overestimated. So think about if the function is decreasing, it's going to be opposite way. Okay, so the graph can help you kind of determine whether which one is better